Okay, hello students. Hope you're all doing well. Um, so another unofficial and unsupported C++ tutorial to help get you guys up to speed if there's things you've forgotten from your C++ class. Okay, let's talk about bits and bytes. Everything in your computer is represented using ones and zeros. It's sort of the atomic structure of, the universe that exists inside of your computer. And, by organizing these ones and zeros in specific ways, we can make more complicated things, like our variables. Like, instead of just using ones and zeros to represent ons and offs, if we arrange them just right, we can represent integers. If we represent them, organize them in a different way, we can represent floats, something a little more sophisticated than integers. If you don't notice, they're getting more and more complex as we go along. And if we organize them in a different way, we can represent characters, which ultimately end up representing strings and sentences and works of literature and yada yada yada. Um, and then you can organize each of these things into arrangements of themselves. So, like for instance, you can arrange integers end to end to end to make arrays of integers and arrays of floats, and have strings of characters. But eventually things become too complex, and you need to organize them in different ways. For instance, if we're going to represent this guy, you know, this dinosaur is made up of several other things. There's skin and bones and musculature and organs and all those kind of things, and they all come together, to sort of like be like this guy. And there's all sorts of different things. It's like, skin is not bone, but it's also part of the dinosaur. Musculature isn't skin, it's not bone, but it's also part of the T-Rex here. Sometimes you need more complex representations as your program complexity or your data complexity evolves. Oh, now thinking back on how I arranged that was the whole purpose of this, the evolution of your data, from atoms to cells to multicellular things to really, really complex arrangements in an organism. It's been years since I've looked at these slides, so So in the previous class that I taught with this, we looked at making some complex arrangements of things, probably in a struct or something. But yeah, so if I think this was like renting a program, it's not where like renting a car, and the car had an ID and the hours of usage and the charge, that you were charging for it. So all of those parameters, could be organized into a data structure where you had the ID, the hours, and the charge associated with a specific car. Similarly, with our dino, we could have our dino.skin or dino.skeleton or dino.muscles, each representing some other complex arrangement of things that's all part of the structure that is the dinosaur. And so, this is where we get into representing things in terms of structures. You can sort of think of structures as being, trying to break this down into to simplistic portions that we can represent using our primitive data types. And there's essentially three ways to do these. There are variable structure definitions, tag structure definitions, type-defined structure definitions, and I know what most of you guys in the class are really wanting to see right now are class examples, C++ class examples. So these data structures, these structs in C and C++, are sort of the primitive version of those things. So instead of having a data type defined where you have variables and functions all defined in one place, these are typically limited to just, a type representation and different fields within it that are like a data type, like an int or a float or a character. Excuse me. And so here's an example of using one of these kind of structures. Now the thing here, if you do it like this makes one single instance of this structure, and it has the variable name student that you can reference. But sometimes you want to reuse these guys. And yeah, this will still give you a single kind here. Yeah, but you can use this to so this is the tagged, that's the variable. So the variable type data structure, you end up with one instance of it, and that's it. So if you wanted to have multiple students, you'd have to repeat this whole thing, but that's duplicating a lot of effort. If you use something like a tagged structure, you can make and I'm air quoting, tag that you can apply to a variable and make a structure of the tag type student and name it whatever you want. So you can make multiple variables be defined of that type. And so here's an example of that. You make your structure called student, and then you can make multiple students, and then specify different sets of information associated with that student. So if you want to play around with this code, you're more than welcome to do so. And then there's type-defined variables. And so they work in a very similar way. You don't have to do struct whatever. This is starting to look a lot more similar to how you define classes. And so you type defined your structure, and you can make an instance of student name, and it essentially functions in the same way as the previous struct, but they're technically different implementations. And so yeah, you can initialize values within your struct based on the order that they were declared. For instance, here we declared name first, GPA, and then ID. You could initialize all of those at once, but you got to do it in exactly the order that you listed them in your struct declaration. So the student name, GPA, and the student ID. And you can also do partial initializations of these guys. So if you want to just initialize the first field, it would just put Adam in the student.name because that was the first one of these here. And the rest of these would be initialized to garbage. You don't actually know what their initial value is going to be. So that's a bit of a disadvantage. This gives you a lot of flexibility, especially in C world, but in C++ world, we end up getting a lot more functionality out of classes because, and yeah, let's switch back to our view here, and there we go. Okay. So you can reference member fields using the dot operator. So the variable name that you defined, dot, whatever field inside your structure you want to reference. Now, one of the things you probably noticed here is this is a variable, this is a variable, this is a variable. What if we want to have functions be part of our data structure? Well, structs in C and C++ don't support that. Okay, now I'm going to whisper the thing that's technically true. Technically you can, because turns out you can make pointers that point to functions. If that was scary sounding to you, just ignore the fact that I said it. That's why I whispered it. So what I'm saying is you can actually emulate the functionality of a C++ class using a structure using something called function pointers, which is kind of cool, but not necessarily something you're going to use on a daily basis. Okay, so next part we're going to cover is we're going to go into examples of classes, but that is the following video. So more examples of working with structures if you want to play around with that. And this code compiles just as well in C as it does in C++, because remember C and C++, actually C is part of the C++ standard. So all this stuff's going to work in there as well. Okay, folks, so hope you're all doing well, staying happy, healthy, and safe.